Ahead and get started. Good afternoon, everyone. I would like to introduce this next session, which is on modernizing the interconnection queue, where we continue discussion about AI, but also add topics of automation and process reform. I would like to introduce our session chair today is Lauren Campbell, and she's the Director of Policy and Economic Analysis at Grid Strategies. Lauren, turn it over to you.
Hello, everyone. Welcome to session 3B. I'm very excited to talk about one of my favorite topics, the interconnection queue. Our session title is Modernizing the Interconnection Queue, AI Automation and Process Reform. We have a great group of panelists today. Just to set the stage a little bit, FERC issued Order 2023 2 years ago, but even before that final rule came out, the RTOs were hard at work processing their backlogs and implementing other reforms. Some of those reforms were similar to those in Order 2023, like moving to a clustered process and adopting readiness requirements. And so the RTOs have been working on that over time. 2 years later, since the final rule, they've implemented or in the process of implementing compliance with everything else that was on Order 2023. But there's still a lot of work to be done, and additional reforms are underway, including AI, the use of AI and automation, as well as other reforms like thinking about the best way to have an energy-only product and integrating transmission and interconnection processes in a more consolidated way. So I will turn it over to our panelists, but first I'll introduce them. We have Jennifer Swierczek, the Manager of Generator Interconnection at Southwest Power Pool, Ryan Westphal, Manager of Generator Interconnection at MISO, Donnie Bielak, Director of Interconnection Planning at PJM, Will Gorman, Research Scientist at Lawrence Berkeley National Laboratory, and Cody, Director of Transmission Studies at NextEra Energy Resources. So each of the panelists are going to give a presentation, and then we will have plenty of time for Q&A. So we look forward to your questions. Thanks.
Hi, everyone. My name is Jennifer Swierczek, and I'm a GI manager at Southwest Power Pool. Recently, we've been working through our backlog, and I also get the opportunity to work on policies and special studies. So the last time I was at ESIG was spring of 2022, and we were really just starting to kick off our backlog mitigation plan. And we were working on the study cluster 2017-002 and 2018-001. So since then, we have been successful accelerating our studies. We've gotten all the way through DICES 2023 Decision Point 2 in a 3-phase study process. And so that's a really significant milestone because that is the last Decision Point 2 of our backlog clearing plan. So it took a tremendous amount of effort. Our developer community, SPP, our stakeholders, our transmission owners, in order to make this happen. And we're not finished yet. As you can see, we've got other studies that are coming prior to the transition to the consolidated planning process. That includes a resource adequacy only study that we have just kicked off. It's underway. We also have a DICES 2024. So with that, we went to FERC and we asked for a delay to the study start of 24, and that would allow more of the backlog studies, everything prior, to clear out just a little bit more for better study assumptions and a better answer for that cluster. And then finally on this one, you see DICES 2026, that we intend that study to become the first consolidated planning process study. And these are some stats on our backlog clearing plan. 24 cluster studies have been completed since 2022. We've studied over 1,600 projects, 340,000 megawatts, and we signed over 190 new GIAs, with more coming this year. So a record number of GIAs. We offer that information on our website so that if there's resources needed, there's a place to go look and see is there existing capacity that you can go get. Our timing has improved. So it took us a while to get there. I've got a slide that shows the peak and how we're coming down the mountain now. But that DICES 24, with the delay, from the time that we start the study in December, we expect to issue the first GIAs December of next year. So that's a 12-month study timeframe that's much better than it's been in the recent past. And then with some of these innovative study, the ERIS resource adequacy study is expected to take around 6 months. And then under the consolidated planning process, from the time you actually start the study to issue GIA is roughly 6 months. So we're working on ways to do it even faster. And here's what that timeline looks like. Again, we generally do focus on when could requests that are part of those particular studies get to GIA. And again, as of September 25, 30 gigawatts have signed GIAs, and we estimate another 40 gigawatts by May of 2026, and that does include this resource adequacy study. It came in at a little over 13,000 megawatts for that one. Now, AI and automation did help us get there, and we've got things that have been implemented all the way back from 2017-002, some things that are in process right now, and then some things that we're looking towards the future. And it's really been key in helping us to meet aggressive study timelines, also get better accurate data starting at the beginning with our intake process and our model builds. And so the left two, I hope I've got my directions right. We implemented with Grid Unity as the vendor. We call it SIMS. That's SPP Interconnection Management System. That's an online application tool where anybody who wants to submit a project to be studied can go online and submit their application. It's checking the data as it comes in. And if there's something wrong with that data, it's sending it back to the customer prior to SPP ever looking at it. So that was pretty significant and resulted in about a 50% time savings. The other thing in this tool that's pretty cool is that instead of endless emails or another ticketing system that's not integrated, you can communicate back and forth through that system. So if something needs to change or if there's a deficiency that needs to be cured, that's also the way to communicate back to that customer and even the transmission owner about their point of interconnection or certain characteristics about the project. Pearl Street, and I think their name has changed to Enverus. I hope I'm saying that right. We've used them to help us to dispatch our steady state models and also solve those cases, providing ready cases for analysis. We've been using that for quite some time. The one that is new with DICES 2024 is this third column. We're calling it Sugar 2. That's where in a phase 1 study, we can automate the steady state analysis. So that's where with their tool, they could make some study assumptions and basically give us a phase 1 result in like 8 times the speed that it would take us to do it. The other thing that does, if you're part of the interconnection world, you might hear about turning the crank. So you turn the crank a couple times during those early stages. And that way, by the time you do get to the phase 2, that includes steady state and stability, you've got fewer requests to study. So that really makes that phase 2 a more accurate and viable study for SPP customers. The other thing that we're looking to automate would be, so if you have the customer information coming in from your online tool and you've got the report itself, then you can start to say, well, take that information and put that into the facility studies that RTOs are responsible for, and also take that same information and put it into the generator interconnection agreement. You know, right now that's manual and just copy paste, and it can be error prone because things change over time. Anybody could make a mistake. So automating that piece of the process could give us more savings as well. And this was our climbing of the mountain and how we're on the downward stretch. So even though we've added studies and we're doing more GIAs than ever, the actual time to study is decreasing. So that's a very good indicator that what we're doing is working. So we're also looking to the future. We've partnered with Hitachi, and from an AI and further automation standpoint, some of the things that we're looking at would be intake and validation of all data, not just the GI, but even the underlying model assumptions that are provided to SPP on at least an annual basis. So having that data where it's accurate, it can support multiple formats, that's going to be that one source of truth that could really help speed up the planning process at SPP, not even just the generator interconnection process. And then sticking with the generator interconnection process, we could then build models and simulate results even quicker than we can with the Sugar 2. And that analysis and reporting, that's a way, again, to have those reports where they're available in a portal and able to keep up with history over time. You know, this is definitely an improvement. If you've been part of our SPP studies, you know, we've got a workbook, we post them. If you're trying to look for something, you download an Excel spreadsheet and, you know, sort and filter. I think at this point, we can do better than that with some automation and some database functionality. All right. Policy. So this was the third piece of the puzzle. The backlog is going well, and SPP is excited to get on to our consolidated planning process, but we're not finished yet. I talked about the ERIS resource adequacy study. There's also a number of special studies that are going to help to get generation connected online prior to the consolidated planning process. High impact, large load generator assessment. That's one of them. And there's a panel discussion on Thursday if people stick around. The first thing when you're looking at a large load to ask is, do you have generation to support that large load? And so we needed to have a product that if you didn't already have that generation and weren't already part of a DISIS study, that you had a way to connect generation just to support that load. So that recently got approved, and we intend to file with FERC. Priority Plus, if you're familiar, we have a surplus process today that you cannot exceed the original studied megawatts. This allows for some incremental capacity that we've never had before. So under certain conditions, you could get up to 20% added capacity for your surplus. That's new, and it helps to meet some non-resource adequacy needs. We talked about DISIS, the consolidated planning process. I've got one more slide on that. Finally, quarterly operating limits. Through a DISIS study, you might have a limiting constraint up until all of your upgrades are built. And so that makes your GIA maybe a little bit less attractive. You also want to be able to produce energy when the market needs it. So this is a study that provides seasonal information other than your DISIS study 4 times per year. So ideally, customers are getting more capacity and a little bit more right time rather than having to continue to submit for a special study just their generator. So this opens it up to anyone who might have a limitation. So onwards to CPP. If you're following the SPP stakeholder process, Consolidated Planning has a task force. It's called the CPPTF, and you can find that on our website. We are at the CPP manual. So this takes the tariff that's proposed and will be filed probably as early as next week. And it says, all right, well, if the tariff says this, then the manual describes how we actually study that. And what consolidated planning process is doing is putting the transmission planning process and the generator process together to try to optimize those upgrades. It's really something new and different that we're excited about. That manual drives the process, the people, and the tools so that we can set up and implement this new process. And we would actually sunset the DISIS attachment V once we've gotten to the last GIAs. of DICES. So attachment V for brand new request would become attachment AY under the new CPP proposal, and attachment V would still exist for those different special study types. So that's what's going on from a policy perspective. We are also expanding to the west, and one thing to look at in that area is what does their network resource interconnection service deliverability areas look like? So we've got some initial results, and we've looked at two options. What if the west is just one big area, one big deliverability area, versus what if it's two? So we are reviewing those results. We'll be working with expansion members to get that solidified. That answer goes into a 2027 ITP for the Western expansion members, and it supports that the West can also come on to the consolidated planning process at the same time. All right, this is the last one for me. I'm a schedule person, and this is what CPP looks like. I'm going to go super high level, not every detail. This summer, 2026 ITP, we provided planned interconnection sites. And that way, customers can know these are sites that have been planned for. And when we actually open the window in April, they could submit actual generator requests. We have a window close after the Grid C is posted, October of 2026. That amount is giving cost certainty to those customers. There's going to be a certain amount for energy resource interconnection service, and then an additional amount on top of that for network resource interconnection service. And then you might also be subject to affected systems. But we have one interconnection cluster study under the new construct where before you commit to that Grid C milestone, 100%, you have all of the information that you need. So that would be your Grid C amount is known. If you came in at a planned site, you do have cost to interconnect, but it's very unlikely to have additional direct assigned upgrade cost. If you come in at an unplanned site, it would look a lot like today. So you might have that additional cost. And GIAs from that process would happen around December of 2027. And though I don't show it, we're really setting up where every single year requests coming through this process would have GIAs each December. So it kind of looks like this over, even though the window itself is a little bit different after the initial one. So thank you very much. I appreciate your time.
I think I'm next, right?
You're next. I was going to say Ryan is next, so thank you. Oh, it's working out. Thank you, Ryan.
All right, well, thanks. And my first time at ESIG, so appreciate the invite and looking forward to the questions and meeting you out in the lobby if we get a chance to meet. So I'm Ryan Westphal. I'm a senior manager in what we call our resource utilization group. Mainly what I do is I'm on the generation interconnection side. My team of engineers are doing all the DPP, what we call the DPP studies, or all the interconnection studies for generators. Call it the resource utilization group because we do a whole bunch of other stuff. And actually, we talked a little bit about at the SPP presentation of some of the surplus replacement. We do a lot of those other type of interconnection processes too. And so tried to be holistic in the name of that. So that's why we call it resource utilization. So I'm here to talk about our automation effort with Pearl Street Sugar. It's the same company that Jessica just talked about. Jennifer just talked about. And we've made a lot of progress over the last year implementing that. But even before that, I want to kind of give you a kind of an overview of where we're at. So right now, MISO has got a large queue volume, as I'm sure most of you are aware. That really started in 2022 cycle where we essentially had an explosion of about 170 gigawatts of requests in that cycle. We had a couple of reforms that came through that. We'll talk about that. And, the backlog is still kind of where we're at right today. We still just basically finished our 2022 phase 1 study using our automation that, well, I'll talk a little bit about. And then, we've gotten the 23 cycle. We had additional reforms, detail here in a second. And then, of course, we skipped the 24, and you don't see the 25 in here because that one literally just closed. We're still kind of processing that. But that was the first one that actually had one of the reforms with the cap in it. So we'll talk a little bit about that. Oh, so here's how you look over time. As I said, with that kind of explosion from requests in the 2022 timeframe, 171 gigawatts. We're down quite a bit from that after we've gone through both the pre-screen and the phase 1 analysis to, I think it's roughly 70 gigawatts. I can't remember the exact number, but it's come down quite a bit through those, processing those through the first decision point. We've just got our 23 cycle. So if you have staff back at home, that 23 phase 1 cycle study is going to be in draft form posted today. So, we just kicked that one off about a month ago. And so we were able to kind of turn that around pretty effectively with our implementation of our automation. So definitely making a lot of progress here in our early parts of the phases, the phase 1 analysis. And then again, in 25, I don't have the numbers here, but it basically, if you're following that, we did hit that cap number, and went over it in that 25 cycle. We'll have some better numbers here coming in the next weeks and months as we process those. And the one thing I do want to just highlight too, again, is I think you heard in a number of the keynotes and some other presentations, at the SPP and PGM, is we have a lot of projects in the queue, but we also have a lot of projects that we have signed generation interconnection agreements. Here at MISO, almost 60 gigawatts, 400 units that essentially have GIAs, but they're just not online yet, for a plethora of reasons, from not having buyers, supply chain, et cetera, et cetera. And so there is a huge number of resources that essentially have everything they need to interconnect to the grid. They just haven't yet at this point. So what are some of those main things that I talked about, some of the reforms that we accomplished here from the beginning? Some recent things that we did start doing, and a lot of these were because I would say started and are a result of that 2022 cycle where we saw that huge uptick of requests. And a couple of things that we did implement were essentially that Q cap. So in the starting at 25, that's capped at 50% of the load that's in that cycle. And so that's in that, starting there. We did also implement some higher milestones, some higher site control requirements to actually get into the queue and have a valid application. So that was performed, and those are in the 23 cycle. So we did see some benefit of that, we think, from reducing the applications from the 22 to 23 cycle. And then lastly, where I'm going to spend a lot of the time here in the next part of the slides, is on our automation effort with Pro-Street Sugar that we've been doing with basically for the last year with them and a little bit longer. And so just a reminder on the MISO process, we have a 3-phase process. Essentially, I like to say it's 3 redos of a similar study. Basically, after projects get the information in those phases, they get to have a decision: do they want to go ahead or do they not? And so they get basically 3 phases of that analysis, and you have decision points between those phases. And as you move forward in that process goes some of the milestone requirements and the like do get more increased. We have more certainty in those projects. So just a kind of reminder of how the process exists today from a phased approach, because this will be important in how we implement the automation effort that we've got today. So automating interconnection studies. So one thing I do want to make clear, because I know it says AI in a lot of the panels, and they're talking, what we're doing right now with Pro-Street Sugar has no AI in it. It's your kind of traditional process and automation effort that we're doing in all there. There's no AI at this point in there. And so what we spent a lot on there is first benchmarking the tool. So we've been using a number of the tools in the industry for interconnection studies. And so one of the first things that we did is we benchmark it. And benchmarking specifically related to, I've got these two power flow tools. Can I come up with the same constraints, right? That's the first place I want to start, because when I get to the other parts, some of that's a little bit more of an art and the science that we'll talk about here. But first, we really focus in, can we get the same constraints? Is this transmission element actually overloaded in both models? And in all cases, when we looked at all that, basically 99% of the constraints were matching between the two models that we had with the tool we've been using and ProStreet Sugar. So after that, we started using that in our 2022 phase one that was finalized using Sugar. And then so we've got the 23 cycle beginning now. And like I said, we're going to be posting at least draft results, hopefully today, as far as I know right at this point. So those will be ready to go for folks to review. And that was all using the ProStreet Sugar tool. So overall, this is kind of, there's a lot more details, of course, underneath the hood here, but this is kind of in my opinion, the level that kind of relays at least enough detail of what we're trying to do without getting bogged down in too much detail. And so after that, basically what we did with that, with the benchmarking is we have basically that middle box, that power flow analysis kind of figured out, right? The constraints can do the DC analysis, can do the AC analysis and verify everything kind of matches there. The pieces that we're still missing that we're working through right now is on the model building creation. So we're still doing that pretty much by hand at this point, unfortunately. And partly of that is we're transitioning our application portal from one portal product to another. And so we had to, we didn't want to build a whole bunch of technology on a platform we aren't going to be using. And so that transition is still happening, should be happening, hopefully transition before the end of the year. And so after that, there's going to be a lot more model creation automation on the front end that's going to really help us kind of move even faster than we have before. In particular, one thing that, to be honest, MISO hasn't done a very good job of in the past is really, checking the models, from a technical perspective, and then be able to give that feedback back to the customer in a way where they can get it to us and then be ready to actually process that result. What's generally happened, and it's kind of the nature of the beast, is right with the backlog we were working on stuff and we let applications kind of come up and it looks good enough. And then of course, when you start QA and QCing it, you always find things that aren't exactly what you expect. And so we want to try to do a better job of that, with our new application portal. And then of course, some of this creation of the models and the QA QC with ProStreet Sugar. And so that's all going to be built up here in the next couple months with that and helping with some of that model stuff. Then the last piece, and actually here's the automated model building. So again, we're gonna be layering this on where we're gonna basically take our MTEP, because essentially, the process is you take a MTEP, which is our planning case, and you layer on all the generation that's coming on. That's fundamentally what we're trying to do. Of course, there's a lot more details than that, right? And so what we're trying to do there is make that a little bit more automated, right? Putting projects in there, voltage schedules, putting the study files updated, and adjustments, and making those power flow now, models available as soon as we can for customers to look at in draft form. So that's essentially what we'll be working on for the next couple months, and really getting that up to speed. And then lastly, which is one of the big pieces of that workflow that there's a lot of, I would say, magic that comes in there, I guess, per se, is right. I think we can all, my engineers can run a power flow, they can push the buttons and they can get the constraints. You've been able to do that for a while pretty quickly, right? The trick becomes, okay, well now, how am I going to fix that constraint? There's a lot of expertise, in the, from transmission owners and other parties that, determine what the best network upgrade is. And there's a lot of time that's dealt with in that. And so one of the things that we did for this process is we automated that process in terms of creating it's way more complicated than this on here, but it's basically a flow chart of decisions you make based off of information you see in the, hey, if something's overloaded 1%, maybe you do this type of network upgrade. If it's 50% overload, well, you got to do something completely different, right? And so that workflow and principles in there are all basically programmed and automated in the tool. And so you literally can build a model, do the constraints, and then tell you all the network upgrades based off of this network upgrade selection, and give you a cost for that in less than a day. And so that's all done basically in an automated fashion. So that's a big speed up of that, is trying to at least get the information in front of folks to be able to make decisions on that. One of the big keys though in all this is, there's been some, customers I've talked to is like, I don't want, it's not perfect, right? And I don't think that was the intent of trying to make this, is to make it exactly perfect where it would give you a network upgrade that's going to work in all cases. One simple example I always kind of articulate that, the program would never need to know unless you had some information that, we don't have now, and maybe it'd be very hard to get to, is, hey, it might say, hey, do a line from A to B because that's the best place, but hey, there's a river right below, between those 2 points. Well, that ain't gonna work. But one of the things that keys in our process is the transmission owners, and the transmission provider, MISO, are the one, they get to look at it, and they get to have the final kind of decision on that and say, yep, I've looked at these, hey, Sugar came up with 80% of them. They look fine to me. They take the other 20% and then they can tweak those and give what we call alternatives to that. And we basically get to feed that back in through the loop and get the final answer in there. So that's one of the big keys, is there's still transmission planners involved in the process. Even after you've automated what you can, there is still a human being, looking at this and say, yep, this actually makes sense. And these ones don't. And here's the alternative you should use instead of that. That's built in today, and it's even built in with this. And so the key is here, we hope that this transparently network upgrade selections, first transparent, there's a white paper out there, everybody can take a look at it. We worked with our stakeholders to create that, but we hope that that gets you to a point where if you have 80% of the network upgrades identified, that, hey, that looks good, and you only have to spend 20% of the time, you've saved a ton of time just by doing that if you've taken care of 80% of them already. And so that's kind of a pretty quick overview of what we've done here at MISO with our automation efforts with Pearl Street Sugar. And thank you. Looking forward to your questions.
We have Donnie from PJM.
Good afternoon, everybody. I'm Donnie Bielak. I'm the Director of Interconnection Planning at PJM. Being the third RTO ISO to present here, probably going to say a lot of the same stuff. It's almost like we talk and compare notes. Yes, I assure you we definitely do that. However, some of our solutions are more tailored. So you've got probably a very similar problem, a similar solution, but definitely tailored to the needs of each individual system. So I'll probably be talking about a few things that are slightly different. Talking about the queue reform, the getting through the backlog, and some of the automation and process improvements that we've implemented here. Some of the highlights that I'm going to cover here. So we started with a backlog of 171 gigawatts back in the end of 2023. And as we started working through that, I'll say all of my statistics are as of July of this year. They haven't changed enough for us to actually reissue new numbers. They're slightly different right now, sitting in October. But as we get new data that's available, we're going to be releasing that probably in the next few weeks, actually. So a little bit of a timing issue with that. So I just stuck with the July numbers, and I heard that my boss was presenting yesterday, so all the numbers that he presented should be consistent with what I'm saying. So we got through a 63% reduction of that backlog through July of this year. We're sitting with a total of 44 gigawatts of signed interconnection projects that are eligible to build right now. On top of that, we also have another 17 gigawatts that are coming out of transition cycle number 1, which were issued for agreement. So those are being worked through as well. They just haven't hit the numbers yet. We also tallied up, we had 29 gigawatts of projects that had signed agreements that voluntarily withdrew in the last 10 years. So that was 29 gigawatts of signed agreements. They had been through the study process, they were eligible to build, and then they decided to withdraw from the construction phase, thereby not coming all the way online to commercial operations. So to tackle our backlog and get through our transition, obviously used a lot of tools, staffing, automation to get through that, similar to what you've just heard in some of the other presentations. And we are on schedule to get back to a normal cycle process April of next year. So you can see this here on the timeline. I just kind of talked a little bit about this, just a visual. Starting with really end of 2023, starting to get through the transition. We had a prioritization of AE1 through AG1, which was our old serial designators. They used to get priority not only by their group, but also by the number which they submitted. That was the old serial process. So we had the fast track, which was all of the projects that had no or very minimal network upgrades required. They went really right through to the agreement phase, and we started getting agreements out for those projects. The ones that had already identified larger network upgrades required, those were prioritized to transition cycle 1 or TC1. So that is what we are currently finishing up right now. So that started early in 2024, and here we are standing pretty close to the end of 2025. Like I said, we are at 17 gigawatts of agreements that were out for negotiation after our third phase of studies in TC1. Earlier this year, we also started transition cycle number 2. Transition cycle number 2 was another large tranche of projects from the backlog, which were eligible to submit and be studied together as a single cycle cluster. We had 1,000 projects that were eligible to resubmit for that. We had about 450 that ultimately proceeded into phase 1, and we are quickly approaching the end of the phase 1 study, and those reports are due out very soon. So the transition cycle was number 1, number 2 studies, and then we're going to look to get to our first fully open cycle process starting in April of next year, and it'll get us on track for a normal cadence of not having to wait very long to submit and then be studied. So we did this through software automation. We also did it through just brute force and strength. We doubled our staff over the last 2 to 3 years. So sometimes you just need to have the amount of engineers to do the studies, do the data analysis, write the reports, negotiate the reports. Sometimes that is part of it. So I'm going to be focusing a lot on the technology part of this, but I want to make sure that everybody knows that part of the way we approach this was also with additional staffing. And you can break down the entire study process into the application submission, reviews, data reviews, the study, reinforcement development, the GIA drafting and negotiation, and then the post-agreement activities, which we have attacked each one of those 5 segments individually to try to compress the timelines and achieve efficiencies. And so looking at each one of those areas, as far as the application submission is concerned, so one of the things that you'll hear from PJM is we're slightly different, is all of our technology effectively was developed in-house. We have met with probably every single software vendor, but just after talks and negotiations of what they have and how it would fit our systems and the work that it would need to do to tailor it to integrate into our processes, we ended up deciding to build a lot of software from the ground up. As far as the application submission process of this, through the last 3 or so years, we've had a Q-scope, which started out as just a tabular version of being able to see load in a planning case and see, well, where is there congestion? Where, if I go to build a generator, am I going to be pushing into flow gates or not? We've had a second release of that. It's now geographically based. It's GIS based. much easier to see, almost like a heat map. You can see, well, this would be good for generators, and believe it or not, also good now for large loads. They're using it for the same purpose. It's not just for siting generation, but also for siting load on the system and seeing what type of impact it's going to have on the transmission. We've made enhancements to our existing QPoint software. That was where the members would submit their applications into. We had to make some changes to that to keep it going. It is on its absolute last legs right now as we cut over to NextGen. So QPoint is being held around really just until the end of transition cycle 1, which will be finishing up in the next couple of months. Then it'll be effectively retired for the interconnection process. And TC2 is already cut over to our new software called NextGen. Cycle 1 is on NextGen. It is much better than what QPoint was, I can tell you for a fact. So a lot of good enhancements that have been done with NextGen, and we continue to build on it. Actually, I think we might even have a production release today, but we have a good schedule of production releases for the new future going through, and having new software enhancements as a part of it. On the study side, QDestination, or QDest as we call it, that was a huge improvement as far as being able to manage all of the software and the study cases and the data and what was in where. So it really helped with all the model building processes. And we also expanded that to use with the TOs. So if you have the coordination between PJM identifying the overloaded flow gates, the TOs identifying mitigations, sending that back to PJM, us running that, verifying to make sure that that works. There's a good portal back and forth with the TOs through QDest. We also have Power Template, which is automated a lot of our GIA drafting and other legal agreement drafting. I can tell you we issued, it was about 200 agreements for TC1 all on the same day, and that had never been done before because of the cluster cycle process and how that works. So we were able to automate a lot of that. It pulls a lot of data out of QDest, automates a lot of the boilerplate language, fills in the blanks where it's needed, and gets that. It makes it a very much quicker process to draft all those agreements. And also InfraTrack, that's another piece of in-house software that we built in planning. I came out of operations, and I said that the control room at PJM probably had about a 15-year head start in implementing technological solutions ahead of interconnections. And InfraTrack was actually modeled off of some of the way the control room does their work as far as outage coordination is concerned. So the InfraTrack took all of these task tracking, milestone tracking, communications, things that were just kind of scattered. And if you weren't the project manager on that, there's no way you could have picked it up and helped out somebody. So if somebody goes on vacation for 2 weeks, that thing was on hold for 2 weeks. But now everything is properly databased, it's standardized. Another engineer can come in, pull up the case, say, okay, well, this is what I'm looking at. Here's where you need to be. And then boom, you're right on track. So that's been a very good way to find efficiencies, especially even with staffing. Some of the quality improvements that we've done here, cost allocation, that was done very manually, and it was very iteratively, especially with the serial process. So we now do that. We automated that. The TO collaboration, just the sending of data back and forth. We had, access databases, spreadsheets, things like that. We now have a much better interface to get that data to and from the TOs and implement it into our studies. Managing the case building and the data changes that go into it, especially if you get a generator that changes its data and you've got a whole host of different parallel cases that are being run. If you database that in QDest, you can then database it in one place and it propagates out properly, ensuring that we don't have any errors in the case building. And then also I talked a lot about InfraTrack here. I've already explained that. That was one of the areas that was absolutely in need of some technological improvements, and luckily was able to get it. So taking a look, we've actually been able to try to take a rough cut at identifying time savings as far as some of these 4 areas here. The cost allocation, something used to be taking maybe 1 to 4 hours to calculate manually, is now done effectively automated, saving 1,500 hours in TC2 and 2,500 hours in TC, 1,500 hours in TC1, 2,500 hours in TC2. The report generation, same thing, saving a significant amount of hours. The validation of the upgrades, going from multiple days just down to 1 to 2 days, and the case building, really going down from months down to weeks. So a significant time savings every step of the way on the process, kind of casting a wide net, seeing where we could find efficiencies and pulling every part of that interconnection process in a little bit. So a quick snapshot of where we are at with some of these numbers that I said before, or where we started. I said we started our backlog with 171 gigawatts back at the end of 2023. 26 gigawatts went through the fast lane. 45 gigawatts was eligible for TC1 and 100 gigawatts was available for TC2. Fast forwarding to the middle of 2025 here, we've gotten all the fast lane done. There's nothing left there. Down to the last 17 gigawatts, which we have now passed the decision point. I don't have the full numbers on that, but that 17 gigawatts is going to actually reduce a little bit. Probably in the coming weeks here, we'll get that data out to you. But that is quickly approaching an end of the TC1 cycle. And then TC2, we're up to 46 gigawatts, which are under study in phase one. That also includes RRI. I have been combining the RRI and TC2 numbers for so long that I cannot off the top of my head tell you how much of that project were RRI. But plenty of press releases out there if you want to go ahead and take a look and say how much went to RRI. Or if you're saying, Donnie, what is RRI? I'm not covering that here today, but that was we opened up TC2 to get new generators to apply to respond to our pricing signals late last year and early this year. So in summary, we've been able to significantly reduce our backlog and we've got end in sight. I would say by April of next year, we should have fully cleared the backlog, and everything that was waiting to be studied will now be under study or completed. Automation and staffing played key roles in being able to find efficiencies and improve quality. And we will continue to invest in new automation and new tools as we go along here. I believe Ryan said, I don't think I mentioned AI once in my presentation. A lot of it is really automation, it's process, it's staffing. But from my experience, when you integrate new technology into a process, slower is better. AI might be 80% right. Well, you get one, it's something that you really need to be close to 100% right. That's not ready for prime time yet. So small chunks, use it, verify it, parallel operations with it before it's ready for something that you can turn over and know and trust. So we're certainly doing some R&D in that field, but really most of our focus has been on automation and process improvements. So I did not have a contact slide, so I just switched to the next presentation. But I'm complete. Thank you.
All right, Will, you are up next. Thanks.
Great. Well, thank you all for joining our panel. I know you had two choices, and I appreciate you all choosing the generator interconnection topic. So as Lauren said, my name is Will Gorman. I'm a research scientist at Lawrence Berkeley National Lab. And with my presentation, we're going to pivot a little bit. I'm not representing an ISO RTO, of course. And I'm not going to be talking about perhaps the more buzzworthy topic of automation and technology solutions to solving generation backlogs, but maybe perhaps a little wonkier or nerdier of a topic, which is the interconnection request type that can be chosen at the beginning of the interconnection process, in particular, energy resource interconnection service. So I will say, perhaps all ESIG presentations and conferences are wonky. So, I think I have a good audience here. So I'm going to be describing a research white paper that was not just the product of my efforts. It was a team of collaborators. And so I just wanted to quickly acknowledge them here. Fritz, who's also affiliated with LBNL, and then some collaborators at Duke University, and Tyler and Dahlia. But of course, everything that I'm saying here today is certainly, my perspective. I don't speak on behalf of my co-authors or my funders, but they certainly were very involved in the material that I'm going to talk about. So just a quick outline. For those of you who have seen LBNL presentations before, you are probably expecting data charts, and this presentation will certainly have data charts. So I will quickly go through some of the motivation, not just for the work on ERIS that I will describe, but really, why we as a panel are together, why ESIG has probably planned interconnection panels for the last 5 years, what trends in interconnection we've seen that have motivated a lot of work and will continue to motivate, a lot of our efforts in the future. And then the last half of my presentation, I'll talk in particular about this ERIS white paper. So all of the data that I'm going to show here is through at the end of 2024, so keep that in mind. We've already heard this from some of the individual ISOs perspective, but the backlogs and the quantity and the volume of proposals in the interconnection queues is really a national story. I mean, really, it's a global story. But given the audience, I'm going to focus on the US story here. In all regions, especially when you're comparing things back a decade ago, 2014, have just seen massive amounts of requests that are quite challenging to process, and why I think a lot of the ISOs and RTOs have implemented automation steps. So this is certainly the challenge. This is why we are talking about the things that we're talking about today. And then when it comes to some of the metrics where we try to measure progress or kind of measure where we need to improve, we really focus on a few. I'm going to show two here in terms of timelines, which have increased pretty dramatically over the last 2 decades across the United States. Timelines from interconnection requests to actually receiving commercial operations date. That's the left chart. And then maybe one of the symptoms or explanations of the problem, which are these project completion rates, which are quite low because a lot of projects end up withdrawing from the process, impacting other projects in the system and causing a lot of work. Also a benefit of automation in order to move these projects more quickly out of the queues. So these are the challenges. These are the baseline metrics that are not really internalizing the progress that I think has already started to appear, and certainly the regulations in Order 2023. A lot of the automation steps I don't think are coming through in our data yet. I think in the years to come, we are excited to track these metrics and see where they go. But this will be hopefully an area of improvement that we start to see. So about a year and a half ago, I was involved in a report that I tried to identify a lot of solutions to interconnection challenges. Automation was actually one of those solutions, and it's having a lot of success. But another one was related to energy-only interconnection. And there was this idea that we should ensure that generators have the option to be redispatched rather than paying for network upgrades. And that is going to be the focus for the remainder of my presentation, and was really the focus of this white paper. And when I think about why we wanted to do this research, it really is driven by industry interest and really 3 considerations within the industry. The first is a desire for more flexibility and choice by resource developers when they are submitting an interconnection request. So different types of interconnection service opportunities. So that's certainly one consideration. The second, which maybe captures most of the headlines that you see, is this perception, at least in the industry, that a well-functioning energy-only service option, a lot of people point to ERCOT's Connect and Manage approach, could relieve interconnection bottlenecks and speed up the queue. Perception is a key word here. Connect and Manage is not ERIS, nor should they be, but I do think it is perception that drives motivation and chatter about what could be in the industry. And then the third, more theoretical, perhaps a more long-term vision, is that the idea that ERIS could improve the utilization of the transmission system, especially as the generation mix is changing, and perhaps changing in such a way that more energy-only resources will be wanting to connect. And if you have that, you want to have a good energy-only service opportunity in your interconnection process. So our goals with the white paper were really to provide clarity around the history and current practice of ERIS, just to level set and make sure everyone was starting on the same page for what the service was designed back in 2003. We also wanted to examine where and why differences occurred and discuss, so we don't kind of explicitly state reforms that should be taken, but at least discuss how it might better be used in considerations for its future. Okay, so now a few more quantitative charts talking about this choice between energy only or energy resource interconnection service and ERIS. When people think about the choice, especially when you're thinking about if you're going to choose ERIS, the idea being that you're going to be using the transmission system on an as available basis, so a less quality, in some sense, type of product, you're hoping to get something for that. And I think some of the two things that people think about are timeline. So maybe they think that they're going to get speed from this, or they think they're going to get some kind of cost savings. So this chart shows comparisons between ERIS and NRIS when it comes to timeline, that those have mostly tracked pretty closely over time over the last decade and a half. Because these are pretty intertwined resources within how we run interconnection study processes. And it also compares it to what ERCOT does. And honestly, they were pretty aligned for a long time. And really the divergence started to happen in the 2018-2019 time period. And the other metric that I mentioned was cost. And so I think also as people think about as available transmission service, maybe you're not paying as much upfront. And that was true also for a really long time. What this chart shows is the percentage of projects that had de minimis or pretty low interconnection costs associated with the study. And that was a high percentage for ERIS, really up until around 2014, when as the transmission system has become more constrained across the country, you also started to see that play out and the costs that are getting assigned to ERIS projects. Okay, so with the remaining time I have, I want to spend a little bit summarizing some of the qualitative work to compare ERIS practice across the country. I don't have a lot more time, 2 to 4 minutes if I go a little bit longer. And so certainly encourage Q&A, questions with me afterwards, because it's tough to summarize a 70-page document in 10 minutes. Real quickly on scope, the scope was all of the ISO RTO regions in the country. Not all regions use the ERIS, NRIS terminology, so I apologize that that is what I've been using. I do list what is used in different regions in this table, the equivalents. And then we also do some case studies at non-ISO regions. We couldn't cover all non-ISO utility areas, but we look at Southern Company, Duke, and Pacificor. So when you think about some high-level summaries of the differences, I think the first question is usually, does your region have an RA program? And obviously, this is what separates ERCOT from all of the other ISO RTOs in the country. So obviously a big driver of the ERIS NRIS distinction. ERCOT does not have an ERIS NRIS distinction because it does not have an RA program. But there are also other key questions, high-level questions that you can ask that differentiate the areas around the country. And those are, is deliverability studied in interconnection? For a long time, it wasn't in ISO New England. It now is. But that's the key question. The second question is our congestion upgrades identified for ERIS projects in the study process? And that's not consistent across all regions. And then the final being, who is paying for the ERIS network upgrades that are being identified? And so that already starts to build out some heterogeneity in the implementation of ERIS, NRIS across the country. There are 4 thematic areas that we tried to cover. I'm not going to talk about all of these, but as it pertains to ERIS, we looked at transmission service, we looked at the interconnection process, interconnection study methods, and the differences as they've been implemented, and network upgrade cost allocation. I think 2 interesting things I'll say on this slide is the first that in MISO and SPP, there is actually an option to qualify for RA if you are an ERIS project via application of firm transmission service. And so there is already some distinctions because that is not applied for the other 4 ISO RTO regions, which is a little bit of an interesting historical element of how these processes are applied. The big kind of area of heterogeneity, though, is certainly on the interconnection study methods. And we bucketed them into 3 main categories of minimum interconnection service, so where congestion really isn't a focus for the ERIS studies, which is in CAISO NISO. There's a case study stringency approach, which PJM and ISO New England have, where a few case studies can lead to congestion upgrades being identified for ERIS, and then flow-based trigger thresholds. So when you think of DFACS trigger thresholds in MISO and SPP. A lot more detail, certainly in the study. 2 more slides, and then I'll be short. The main point to make on the non-ISO work is that it's a lot less transparent. So it's harder actually to tease out some of the differences. The nice thing about the ISO RTO regions is that a lot of this information is in business practice manuals. But ultimately, with non-ISOs, there's an interaction between federal level regulation, where this ERIS NRIS distinction comes from, and state level industry structure and procurement strategies. Procurement strategies that are state regulated and might actually prescribe the need for firm transmission service. And it calls into question what is the meaningful use then of ERIS and NRIS if your state level process is going to require a certain type of procurement. So I think there's a lot of considerations and a lot of questions that we ended the white paper with. I think ultimately, you need to establish what are your goals from creating a different and distinct interconnection service type. If it is faster interconnection, that is going to have implications for how you design the process and whether you need an off-ramp rather than commingling all these studies into one cluster. There are some more fundamental questions about congestion and competition policy and market design and how market participants understand what congestion is and therefore what it means to have an energy only or to select transmission on an as available basis. And then really in the non-ISO region, I think there's a question of the meaningfulness of the ERIS NRIS distinction. I mean, Southern Company has gone as far as to state that they don't see much meaning to NRIS because you ultimately have to apply for firm transmission service via a separate transmission study process. So those are some of the considerations, but I think I've overstayed my welcome a little bit, but thank you for your time and look forward to the Q&A.